In the world of nanotechnology, researchers are constantly exploring the unique properties of nanoparticles. And a study about the mechanical properties of silicon nanoparticles has been made by Jesus Loera, Karen Lopez, Sergio Mejía Rosales, and Juan de la Rosa. The first part is introduction. This study focuses on the mechanical response of 40 nanometer spherical silicon nanoparticles with cubic diamond structure. The effect of crystalline orientation and the presence of a solid or hollow core on the elastic properties of the nanoparticles are investigated using molecular dynamics simulations. The result says that hollow nanoparticles are often softer than the solid nanoparticles, and we observe a phase transition in the internal structure from cubic diamond to silicon beta tin. The following part of the investigation is the atomic models. We have a studied system that includes solid nanoparticles and hollow nanoparticles, both composed of silicon with different crystallographic orientations. The difference in the atomic arrangement for each orientation are analyzed. The effect of compression of the nanoparticles with a plane indenter along 4 different crystallographic orientations was studied. In this picture, in the figure 1, we can see the difference between a hollow nanoparticle and a solid nanoparticle. And in figure number 2, we can see the difference between the atomic arrangement in the 4 different crystallographic orientations. And now the results. After running the simulations, we analyzed the force displacement and stress strain curves for each nanosphere because this graph contains information about the mechanical response of the system. Specifically, they say how hard the nanoparticle is. It is observed that hollow nanoparticles are softer than solid nanoparticles. Also, a coordination analysis revealed a phase transition in the internal structure of the nanospheres is identified. The silicon goes from diamond to beta tin, leading to a denser structure and hardening of the nanosphere. In figure 4, we can see the force displacement and the stress strain curves. In blue, you can see the solid nanoparticles, and in red, the hollow nanoparticles. At the left, we can see the force displacement curves, and in the column of the right, we can see the stress strain curves. In figure number 5, we can see a coordination analysis for each of the 4 different orientations. And in figure number 6, we can see the coordination analysis both in a visual way. You can see in the figure number 6 how the silicon goes from a diamond structure in green to a silicon beta tin structure in red when the compression goes from strain 0 to strain 0.6. So for conclusion, the force strain curves show that hollow nanoparticles are softer than solid nanoparticles, and the coordination analysis said that a phase transition in the internal structure of the nanosphere is observed, leading to hardening, and the stress curves indicate that hardness of hollow nanoparticles is more regular compared to solid nanoparticles. Specifically, the 110 orientation shows a slightly higher hardness. And that's all. Thank you very much.